Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. Area of rectangle ABCD is 2 times that of square BCEF. What is the value of alpha plus beta, where alpha and beta are angles as indicated in the figure? This was a question that was asked at a high school math test. I believe it was 8th grade. And this problem may appear trivial to people who are familiar with advanced trigonometry. But the real challenge is, how do you solve this problem from the perspective of an 8th grader who doesn't have that advanced level knowledge of trigonometry? And I'll try to do that. But first of all, let me start with, indicating some of the dimensions. So starting the side of the square, BCEF, let's call the length of each side of the square as x. So CE is x, and so will be EF. Now, it's given that the area of the rectangle ABCD is 2 times that of the square BCEF. And the rectangle obviously shares a common side with the square. So the longer side of the rectangle, DC, must be equal to 2 times the side of the square, so that its area can be 2 times that of the square, because the area of the square is x square, and then the area of the rectangle will be x, because x is one of those common sides, multiplied by 2x, so that would make its area 2x square. So the area of the rectangle, for the area of the rectangle to be 2 times that of the square, the longer side of the rectangle would have to be twice the length of the side of the square, because the rectangle is sharing a common side with the square. So with these dimensions laid out, for those who are familiar with the knowledge of trigonometry, it's pretty trivial to obtain the tangent of those angles alpha and beta, tan alpha and tan beta. And once you obtain tan alpha, tan beta, you have to apply, slightly higher level trigonometry knowledge to obtain tan of alpha plus beta. And there's a formula for that, and that requires a slightly advanced level knowledge of trigonometry, which is not again expected even in standardized tests like GRE, GMAT, SAT, etc. So the real challenge is how to solve this problem without use of trigonometry. And that's where it took me actually quite some time to figure out this problem. How do I solve this just applying simple knowledge of geometry expected of high school students or middle school students without using any formula from trigonometry? So how do you do this? We start with some construction, and this is basically key to figuring out this problem. So the construction that we do is we first locate the midpoint of the side DC. And from that midpoint, we draw a line parallel to the sides AD, BC. Let's call that midpoint as M. So this is midpoint of DC, the side DC of the rectangle. And from M, we draw a line perpendicular, and that makes this line parallel to the sides AD, BC, and EF, right? And the length of this line, we draw it in such a way that the length of the line is 2 times x, right? And let's call the point where it meets AB as N, and then the other extreme as O. So we have this line OM whose total length is 2x. What is the length of DM? Well, we took M as the midpoint of DC, so that makes DM equal to half of DC, which is x, because DC is 2x, so half of DC will be simply x, right? And what about the length of NM? Well, by our construction, right, NM was parallel, right, to the sides AD, BC, and FE, and that makes NM equal to those sides. So NM will be simply equal to x. What about the length of ON? Well, we know that OM as a whole, it's 2x by construction, and NM is x, so that makes the length of ON equal to x. Now, we also consider what's the length of this line segment, NF, right? Well, we know that NB should be equal to MC, right? Because this is all parallel to each other, right? And MC, M being the middle point of DC, MC is x, right? So that makes NB equal to x, and then BF being the length of the side of the square is also x. So that makes the length of NF equal to 2 times x. So having worked out these lengths is important. Again, this is not very difficult to conclude what those lengths are, because we have this nice construction, everything is parallel and symmetric, and it's pretty apparent, but just wanted to mark those up. As the next step, what we do is we join the point D to O by a straight line. So we join the straight line DO, and we consider the triangles DOM and ABD. Now, in triangle ABD, the length of AD, it's equal to x, right? What about the length of AB? Well, it's the same as DC, right? Because AB and DC are opposite sides of a rectangle. So AB, the length of AB will be 2 times x. Now if we consider the triangles ABD and DOM, their corresponding sides DM is equal to AD is equal to x, right? And then the other side, OM, is equal to AB equal to 2x. So those two corresponding sides are equal. And the angle included between those sides is 90 degrees for each case, for each triangle, right? So that makes triangle DOM congruent to triangle ABD by the side angle side congruency, right? And as a result of this, angle DOM, that's marked in green, will be equal to angle ABD, and we know angle ABD is given as alpha, so that makes angle DOM equal to alpha. Next, we join the points O and F by a straight line, and we have this triangle OFN, and note that this is another right angle triangle where one side ON is equal to x, right? The other side NF is equal to 2x, and the angle between them is 90 degrees. So that makes triangle OFN congruent to triangle ABD as well as triangle DOM. So As a result of this, the angle OFN, which is marked in red, that should be also equal to alpha, right? And if angle OFN is alpha, we know that in triangle OFN, angle ONF is 90 degree. Of the other two angles, one of those angles, angle OFN, is alpha. So that makes the other angle of the triangle, which is angle FON, equal to 90 degree minus alpha, right? Because in a right angle triangle, the sum of the other two angles should be 90 degrees, right? So that makes angle FON 90 degree minus alpha. Now consider the whole angle DOF. So what is angle DOF? Well, it's alpha, that's the part of angle DOM, which is alpha, plus angle FOM, which is 90 degree minus alpha. So together they will make 90 degrees. So alpha plus 90 degree minus alpha, together they make 90 degrees. So that makes angle DOF equal to 90 degrees. Now, from congruency of triangle DOM with triangle OFN, we basically have DO is equal to OF, right? Because they are corresponding sides of congruent triangles. So they should be equal. And if those two sides are equal, then considering triangle DOF must be an isosceles triangle because two of its sides are equal. But one of those angles of triangle DOF, namely angle DOF, is 90 degrees. So triangle DOF is not just an isosceles triangle. It's a special kind of isosceles triangle, which is a right-angled isosceles triangle. And in a right-angled isosceles triangle, the angles are 90, 45, 45. We already know that angle DOF is 90 degree. So the other angle of the triangle DOF, it being a right-angled isosceles triangle, the other angle, namely angle OFD, must be equal to 45 degrees. But what is angle OFD? Well, we can clearly see it as the sum of those two angles alpha and beta, right? Because part of that angle is angle OFN, which is alpha, and the other part is beta, which is already given. So it's pretty evident from our constructions that angle OFD is simply alpha plus beta. So that makes alpha plus beta is equal to 45 degrees. So the correct answer in this case will be 45 degrees, or if you're expressing your answer in radians, it's pi by 4.